Hey there, math students. Welcome to Solving One-Step Equations, Day 2. So yesterday we were talking about adding and subtracting within these equations, and today is going to be more about multiplying and dividing. If you have any questions about yesterday's assignment, be sure to send me a message or take a good look at the answer key or watch the video again or join one of our Zoom study sessions. Again, those are Mondays at 11 and Wednesdays at 2. Information on the Canvas homepage for math. And if you feel great about that topic, then awesome. Let's go ahead and get going on today's notes. So your can statement, I can solve one-step equations. So let's look at the warm-up real quick. How can you undo multiplying by 5? You guys, you haven't really learned this, so if you don't know it off the top of your head, that is fine. But if you want to undo multiplying by 5, you want to do the opposite, which would be to divide by 5. So we're using that inverse operation of multiplying. So divide by 5. We're going to talk a lot more about that later in these notes. How do you undo dividing by -2? Again, we're going to use the inverse operation. You haven't learned this yet. Don't worry about it if you don't know. The inverse operation of dividing is multiplying. So instead of dividing by -2, you're going to multiply by -2. Okay, and what is 0 divided by 22? Well, I bet you know that 0 times anything equals 0. I want to make sure you also know that 0 divided by anything equals 0. So 0 divided by anything equals 0. Okay, the goal of solving an equation is to get the variable on one side all by itself. That variable has to be alone. So we can read off the answer on the other side. Oh, sorry. Okay. The answer, in other words, the solution, is the number that makes the equation true. Now, this may sound familiar. It's kind of a review from yesterday. We solve equations using inverse operations. That's what I was talking about up here in the warm-up. Inverse operations undo each other. So like if I gave you 5 cookies, that'd be kind of like +5. But then what if I took away 5 cookies? I would undo what I had done before. That would be like -5, and you'd be left with 0 cookies. Inverse operations undo each other like that. So the inverse of adding is subtracting, and the inverse of subtracting is adding. So they're inverses of each other. It goes both ways. Same thing with multiplying and dividing. The inverse of multiplying is dividing, and the inverse of dividing is multiplying. That goes both ways also. Okay, now let's solve some basic equations using multiplication and division. Show all work. Okay, yeah, that's important. When you're turning in your homework, try not to give me just a bunch of answers. I would love to see your process. So kind of like what I'm about to write here is what you should model when you're doing those assignments. This says 5x equals -35. What are the 5 and the x doing to each other? They're multiplying, right? This is a multiplication problem. So in order to undo multiplication, we need to divide. All right, so I just kind of underlined that because I was wanting to emphasize it. But now let's turn that underline into a divide by sign. We're going to divide by the number that we want to get rid of, which in this case is the 5. Now, why are we trying to get rid of the 5? Just because we want the x by itself. We want the x to be alone so that we can solve the equation. So we're going to get rid of 5 by dividing by 5. Now the golden rule of equations is that we have to, whatever we do to one side, we have to do to the other side. So let's divide the other side by 5 also. And that is going to leave us with, let's see, the 5 divided by 5. We're going to cancel that. We'll talk more about that in a second. So that just leaves us with x. And over here, -35 divided by 5 is going to be -7. And that's your final answer. If you're ever not sure you're right, you can evaluate it by plugging that 7 in where the x is, and then just think through it. 5 times -7 equals -35, and that's what it gives us here. So yay, did it right. Okay, let's read our note here. It has to do with that canceling. When undoing addition and subtraction, they cancel to be 0. You might remember that from yesterday. However, when we undo multiplication and division, they cancel to be 1. Now, so what are we talking about here? Well, let's take a look. 5 divided by 5 equals 1, not 0. We don't want it to equal 0 in this case. With multiplication and division, we want it to equal 1. Why do we want it to equal 1? Because 1 times x is just the same thing as x. 1x and x are the same. If you had 0x, then that's not the same as x, because 0 times x would just be 0. So anyways, when we cancel it, when it equals 1 with multiplication, we can cancel that. Whereas with addition and subtraction, we can only cancel it when it equals 0. Let's keep going. You'll see a few more examples. If that's confusing, just stick with me. Here we have y divided by negative 2. So we want to keep that y, but we want to get rid of this negative 2 here. It is in the way. We need the y by itself. So right now, if y is being divided by negative 2, what's the inverse operation of division? Multiplication. Good. So we're going to multiply both sides by negative 2. And here's how I do it. I just write a little dot for multiply, and then I write the number, negative 2. Dot over here, negative 2, because what we do to one side, we have to do to both sides. Now this negative 2 and that negative 2 are going to cancel and leave us just with y. And then 10 times negative 2 is going to be negative 20. And then we're done. If you want to double check your work, think about negative 20 being here, where the y is. Negative 20 divided by negative 2 equals positive 10. Looks like we're right. Good. Don't worry about this note, just ignore that one. Let's go on to C. 12 equals negative 2n. Again, is this multiplication, division? What is it? This multiplication. Good. So we're going to get rid of that negative 2 by dividing by it. Okay, divide by negative 2. Divide by negative 2. These two are going to cancel. And now 12 divided by negative 2 equals negative 6. And then the only thing left here is the n. So that one is solved. N equals negative 6. Let's do another one over here. Right now, m is being divided by 6. We need the n by itself. So let's get rid of the 6. Right now it's a division problem, so we're going to use the inverse, which is multiplying. So times 6 on both sides. We'll get rid of that 6. That will cancel out to 1. 6 times 9, oh, what's that? 54. So here, negative 54 equals m. All right. Okay, so there are a few interesting types of one-step equations on the assignment. Oh boy. Solve each equation using inverse operations. Show all work. Okay, so this is interesting. We have negative x equals negative 29. What are we supposed to do with that negative sign? Could we just say that x is by itself and we're done? No, because x is not by itself. X is not by itself until it's positive. We need to get rid of that negative sign. So I like to think of this as a negative 1 times x. Okay? Now that you have this multiplication problem, in other words, negative 1 times x, right? To get rid of that negative 1, all you have to do is divide by it. So divide both sides by negative 1. These will cancel, and you're left with x equals negative 29 divided by negative 1 is going to be positive 29. And then that's done. This next problem is kind of similar. We have 39 equals 28 minus y. Okay, this is a really good one. First of all, we want the y by itself, right? Okay, so we need to get rid of this 28. Let's subtract it out. It's a positive 28, so we're going to get rid of it by doing minus 28. And then over here, we're going to go minus 28. So these go to 0, so they cancel. 39 minus 28 is going to give us 11 equals, now watch what I do. I'm not just going to write y here, because it's not just y, it's minus y, or negative y, so that's what I have to write right there. Now to get rid of that negative, right now it's a negative 1 times y, so to get rid of that negative, it's kind of like over here. I need to divide both sides by negative 1. And that is going to give us negative 11 equals y, which is the same thing as y equals negative 11. It doesn't matter what order we're in. And that's the answer to your problem. Okay, let's keep reading. Instead of multiplication or division to finish the equations above, you can think of what negative means. For example, if we had negative x equals 7, we could simply say we don't want negative x. What we want is its opposite, which is positive x. So we don't want 7, we want its opposite, which is -7. So they're saying instead of thinking of the -1, you could just think the opposite of both sides. If that makes more sense, you can do that. Let me write this. We want its opposite, which is x. So we don't want 7, we want its opposite, which is -7. So if that makes sense to you, use it. If that doesn't make sense to you, use the -1 thing. Okay, and now on the worksheet. There's quite a few problems here for you. Again, today I'm going to ask you to do the first 14. So you can stop right there and not worry about all those. Let's do a couple of examples for you. Why not start with number 1? We have x divided by 8. So does anyone remember what the inverse of division is? Multiplication. And if you want to just pause the video right now, see if you can do this on your own, I think that'd be a great idea. I'm going to keep going. So we're dividing by 8, which means to undo it, we're going to have to multiply by 8. I'm going to put times 8 here and times 8 there. Those are going to cancel out. 8 divided by 8 equals 1, so they just cancel to 1. I'm going to cross them out. X equals -5 times 8 equals -40. And then we're done. Okay, let's do problem number 4. 2n equals 20. Okay, so 2 times n equals 20. What's the opposite of multiplication? Division. What are we going to divide by? We're going to divide by the number that we want to get rid of. Now's a great time to pause the video if you want to try it on your own. We want to get rid of the number 2 because we want the n by itself. So if we're getting rid of the 2, we need to divide by 2. And we're going to make sure we do it on both sides. Those cancel out and go to 1. And then we have n equals 10. And that is our final answer there. Okay, let's do one more. How about, let me see if there's anything trickier on the other page. I don't know if it's trickier or not, but let's just do number 14. You have x divided by 3 equals -7. So right now it's being divided. We want to do the opposite of that. We want to get rid of the 3 by doing the opposite. So we're going to do times 3 times 3. Those will cancel. And now x equals whatever -7 times 3 is, and that is -21. All right, so first 14 problems on your own. If you have any questions, please let me know. Bye, guys.